C. Members, in this example, we have the values. These are values of initial rates for the reaction, which involve the two molecules of A and B, giving you one mole of C and one mole of D. So this is the experiment number. This is the several concentrations, respective concentrations of A, respective concentrations of B, and the respective initial rates. So find the order of reaction with respect to A, the order of reaction with respect to B, and the overall order. Then find the value of the rate constant and find the initial rate when the concentration at T is equal to 0, for A is 0 point that, and for B that. So let's right away get the answers. So the rate would be, remember we have two reactants. So this is going to be K, A, and B. So here X, here Y. So let's find out what is that going to be. Consider A being a constant, B varying. So what is that going to be? The rate is already carrying, here is 5.6 divided by 1.4. So 5.6 divided by 1.4. Okay, let me indicate this so that some of you don't get confused. So times the concentration of A, the concentration of A is already constant. So we are saying this is 0.15 divided by this divided by K, 0.15 to power X. Then we are multiplying it by what is the concentration of B. Concentration of B is, we have 0.5 out of 0.25 power Y. So what do you think is going to be the value? So this will cancel, and this is going to be 4, and 0.5 divided by 0.25 is 2 power Y. So I will have 2 squared equal to 2 power Y, and Y is equal to 2. Then let's consider when this is a constant, for example, in experiments 2 and 3, then while A is varying. So to determine X, consider A varying and B concentration constant. So how is that going to be? You obviously have rate, which is equal to K. Concentration of A is known as X, concentration of B is Y. So let's substitute in here in experiments 2 and 3. So when we consider experiments runs 2 and 3, we'll find that the rate is going to be what? The rate here is 2.8. So I'll have 2.8 divided by 5.6. Okay, 5.6, which will be 2.8. So we are saying this is the one. So this B will go out, and we'll have 0.075. 0.075 divided by 0.15. This is to power X. So what happens is going to be 1 out of 2, which is equal to 1 out of 2 power X. So meaning, so we'll have 2 to power negative 1, which is 2 to power negative X. So X is equal to 1. So what is going to be the rate equation? So rate equation is going to be rate is equal to K. For A, X is equal to 1. So for B, this is going to be the rate equation. We are to determine the order of reaction with respect to B. We have already determined. With respect to A, we have determined. Then the overall order. So overall order of the reaction is going to be 1 plus 2, giving us 3. So this is a third order reaction. Then find the initial rate of reaction when this is equal to that. So let's substitute in. First of all, we need to determine K. K is going to be rate divided by A and B concentration squared. So what is the rate? We can consider experiment 1. If we consider experiment 1, B is 0.25 and that 1.5. So I'll have 1.4 times 10 to the power negative 5 divided by A, which is 0.15 and 0.25. 0.15, 0.25 squared. So I have 1.4 exponent negative 5 divided by 0.15 divided by 0.25 squared. So I have 1.49. So K is equal to 1.493 times 10 power negative 3. And this is in per mole, decimeters power 6 and per second. Then what about the rate? The initial rate, given that this is 0.12 and the other one is 0.22. So 0.12, okay, times 0.22 times 1.493 times 10 power negative 3. So what is this going to be? Times 0.12 times 0.22. 0.12 times 0.22 times 1.493 exponent negative 3. So we have 3.94 times 10 power negative 5, and this is in moles per decimeter cubed per second. So that is it, ladies and gentlemen.